Today, I'll examine three significant developments in hydrogen's global trajectory. The discussion begins with Western Australia's substantial financial commitment to green hydrogen, as detailed in a recent Mining Weekly report on an 814 million Australian dollar investment. Next, an analysis from RealClearEnergy explores hydrogen's potential to support U.S. energy dominance under the incoming administration. And finally, Yahoo Finance provides insight into Invenergy's milestone achievement with its first operational clean hydrogen facility in Illinois. These developments underscore hydrogen's critical role in decarbonization, supported by detailed technical specifications, economic projections, and broader contextual analysis. All of this on today's Hydrogen Podcast. First up is a report from Mining Weekly published on March 20th of this year detailing Western Australia's green energy push, which gains momentum with an 814 million Australian dollar hydrogen boost. The Australian federal government has allocated 814 million, or equivalent to approximately 540 million US dollars, to the Murchison Green Hydrogen Project in Western Australia's Midwest region, marking the first major award under the Hydrogen Head Start program. This initiative, led by Copenhagen Infrastructure Partners, or CIP, exemplifies a strategic shift toward renewable energy in a state historically reliant on iron ore and natural gas exports. Western Australia boasts a renewable energy potential of 5,000 megawatts, this according to the Australian Renewable Energy Agency, or ARENA, positioning it as a prime candidate for green hydrogen production. The Murchison project integrates 2,000 megawatts of planned wind and solar capacity, comprising approximately 500 wind turbines at 4 megawatts each and 1,000 hectares of solar panels at 1 megawatt per hectare, targeting an annual output of 300,000 tons of green hydrogen by 2030, sufficient to decarbonize heavy industry or power 20,000 hydrogen-fueled trucks. From a technical perspective, the project employs 1,500 megawatts of proton exchange membrane, or PEM, electrolysis, requiring 50 to 55 kilowatt hours per kilogram of hydrogen produced. This translates to 4.5 terawatt hours of electricity annually, with 90% sourced from renewables and matched hourly to meet Australia's stringent green certification standards. The daily production of 820 tons will be transported as liquid hydrogen at negative 250 degrees Celsius, requiring 20 liters per kilogram via pipelines or specialized trucks. Water consumption is significant at 9 liters per kilogram for electrolysis and an additional 20 to 30 liters for cooling, totaling 12 to 18 million liters daily, and sourced from desalinated seawater, leveraging the region's 100 billion liters of brackish groundwater reserves. PEM technology's efficiency of 80 to 85% surpasses alkaline electrolysis 65%, reducing energy costs by approximately 50 cents per kilogram at a 5 cent per kilowatt hour electricity rate, enhancing operational viability. Economically, the 814 million Australian dollar investment addresses the current production cost range of $3 to $4 per kilogram, aiming to align with market prices of $2 to $3 per kilogram and achieve a target of $1.50 to $2 by 2030, as projected by the Hydrogen Council. The total project cost is estimated at $2 to $3 billion, encompassing $1,500 per megawatt for electrolyzers, $1 billion for renewable infrastructure, and $200 million for desalination and pipeline systems. Annual revenue at 300,000 tons could reach $900 million at $3 per kilogram, or $600 million at $2 per kilogram post-subsidy, yielding a 20% IRR over 20 years. The initiative is expected to generate 2,000 construction jobs and 500 permanent operational positions, contributing approximately 0.3% to Western Australia's $180 billion GDP. Furthermore, potential exports to Japan and South Korea, which collectively aim to import 3 million tons by 2030, could add $1 billion annually to the state's economy, this according to ARENA estimates. In the broader context, Australia's $2 billion Hydrogen Head Start program, initiated in 2023, seeks to establish 1 gigawatt of hydrogen capacity by 2030. The Murchison project's 1.5 gigawatt scale exceeds this target, supporting the nation's ambition to capture 15% of its $70 billion energy export market through hydrogen. Challenges include grid enhancements, estimated at $500 million, and water logistics. Yet Western Australia's untapped 5 gigawatt renewable potential positions it as a global leader in green hydrogen production, demonstrating industrial scale feasibility. Next, let's examine an analysis from RealClearEnergy, which is published on March 19th of this year, titled Hydrogen Can Help Administration Meet Energy Dominance Goals. And this is authored by Matthew Kandrick of the Consumer Energy Alliance. With a new U.S. administration poised to assume office in 2025, this article positions hydrogen as a strategic asset for achieving energy security and economic prosperity, aligning with long-standing national priorities. The United States currently dominates global energy production with 12 million barrels of oil daily and 100 trillion cubic feet of natural gas annually, yet faces increasing pressure to transition from hydrocarbons due to climate imperatives. Hydrogen has been a topic of interest since the 1970s oil crisis, with 10 million tons of gray hydrogen produced annually from natural gas for industrial use. The Department of Energy's 2021 hydrogen Earthshot targets $1 per kilogram for green hydrogen by 2030, supported by the IRA's $9.5 billion allocation for hydrogen hubs, framing hydrogen as a bridge to clean energy dominance. Now, technically, green hydrogen production via electrolysis requires 50 kilowatt hours per kilogram, costing $2.50 at 5 cents per kilowatt hour from solar or $1.50 at 3 cents from wind. Blue hydrogen, derived from steam methane reforming with carbon capture, emits 8 to 10 kilograms of CO2 equivalent per kilogram, but achieves $1.50 to $2 per kilogram with the 45Q tax credit of $85 per ton for carbon sequestration. A 100 megawatt plant produces 3,500 tons annually, scaling to 1 gigawatt across 10 facilities yields 35,000 tons, sufficient to power 2,300 heavy-duty trucks or a mid-sized steel mill. Storage solutions include salt caverns capable of holding 500 tons for a $20 million investment, while existing pipelines can transport 1,000 tons daily at 20 cents per kilogram over 1,000 miles. This is according to DOE data. Hydrogen fuel cells with 60% efficiency compared to diesel's 30% deliver 100 kilowatts for a truck's 500-mile range, enhancing energy utilization. And from an economic standpoint, the U.S. hydrogen market, which is currently valued at $15 billion in 2025, is projected to reach $50 billion by 2030, with 25% attributed to transportation, this per McKinsey. A 1 gigawatt hydrogen hub costs around $1 to $1.5 billion, including $500 million for electrolyzers, $500 million for renewables, and $200 million for infrastructure. The IRA's 45E credit provides $3 per kilogram, adding $105 million annually for 35,000 tons, while the investment tax credit, or the ITC, reduces capital costs by $300 to $450 million. And at $3 per kilogram, revenue reaches $105 million annually, with a $50 million profit yielding a 15% IRR. The DOE forecasts 140,000 jobs by 2030, contributing $100 billion to GDP, while exports to Europe, targeting 10 million tons, could generate $10 billion annually, rivaling liquefied natural gas's $30 billion trade. Policy considerations tie hydrogen to the concept of energy dominance, a priority emphasized during the previous administrations and reiterated here. The U.S. leverages 1,600 miles of existing hydrogen pipelines, 40 gigawatts of installed wind and solar capacity, and vast natural gas reserves for blue hydrogen production. Growing Republican support for IRA credits, evidenced by 21 House members as of March 10th, ensures continuity for $382 billion in clean energy investments since 2022. Challenges include grid modernization, estimated at $20 billion, and electrolyzer costs of $800 per kilowatt. Yet hydrogen's alignment with abundant domestic resources positions it as a cornerstone of U.S. energy strategy. And last, let's take a look into a development reported by Yahoo Finance on March 20th of this year. Invenergy's first clean hydrogen project reaches commercial operations. Invenergy, the largest privately held clean energy developer in the United States, has commenced operations at its 5-acre Sauk Valley Hydrogen facility in Rock Falls, Illinois, marking a significant step in integrating hydrogen into existing energy infrastructure. Invenergy manages 33 gigawatts of clean energy projects, including wind, solar, and natural gas, with 22 facilities in Illinois alone. The Sauk Valley project, adjacent to the 980 megawatt Nelson Energy Center, which is a gas-fired plant, represents the company's initial foray into hydrogen production. Illinois, which is a Midwest industrial hub, accounts for 5% of the U.S. hydrogen demand, driven by refineries and steel manufacturing, making this facility a strategic pilot. Technically, the Sauk Valley facility likely employs a 5 to 10 megawatt PEM electrolyzer, producing 200 to 400 tons of hydrogen annually, or 0.5 to 1 ton daily, operating at 50 kilowatt hours per kilogram with an efficiency of 80%. It consumes 10 to 15 megawatt hours daily sourced from Illinois' grid, 15 gigawatts of wind and 2 gigawatts of solar per the Energy Information Administration. The primary application involves blending hydrogen for turbine cooling at Nelson, displacing 100 to 200 tons of gray hydrogen, which emits about 10 kilograms of CO2 equivalent per kilogram. Excess production is transported off-site as liquid hydrogen. Annual CO2 reductions range from 1,000 to 2,000 tons based on Invenergy's 10-to-1 emissions avoidance ratio. Economically, the facility's construction cost is estimated at $5 to $10 million, reflecting $1,000 per kilowatt for a 5 to 10 megawatt system, this per IRENA data. Producing 400 tons at $3 per kilogram generates $1.2 million in annual revenue, with costs of $750,000 for electricity at 5 cents per kilowatt hour and $200,000 for operations and maintenance, yielding a $250,000 profit and a 10% IRR. Incorporating the 45V tax credit at $3 per kilogram adds $1.2 million annually, elevating it to 25% IRR. The project supports 20 to 30 construction jobs and 5 to 10 operational roles, contributing modestly to Illinois' $1 billion clean energy economy. Scaling to 100 megawatts by 2030, which is a $100 million investment, could yield $5 million annually at 1,000 tons, serving local transport or industrial clients. This milestone significant lies in its demonstration of hydrogen's practical integration. Adjacent to a 980 megawatt gas plant, Sauk Valley's 400-ton output tests blending and distribution, aligning with the DOE's $7 billion Midwest hydrogen hub near Chicago. While the current 80% hydrocarbon-based grid poses a challenge, Illinois' renewable growth and Invenergy's 33-gigawatt portfolio signal scalability. This facility underscores hydrogen's immediate applicability, paving the way for broader adoption in the U.S. clean energy infrastructure. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.